Hey guys, Mr. Adamson here. Welcome to another lesson in Science 24. Today we're going to talk about electrical energy and how it is processed and the different methods that go along with that. So the first thing that we're going to talk about when talking about generating electricity, we need to talk about the generators themselves. And generators make electricity through moving a coil wire through a magnetic field. Now on the right hand side here you can see in this figure 6.4, a generator consists of a magnet and a coil of wire. Spinning the coil of wire through the magnetic field is one way to generate electricity. So as it's spinning around there is electrons that are being excited, and that's a form of electricity. Now if we go over to figure 6.3 here, we can kind of see the overall conversion process. And the first thing that you need to have is an input energy. So something that's coming into the system. So something that's moving. And energy due to motion is kinetic energy. What that is going to go to is to a converter. So it's going to change that input energy in the form that it's coming in into the electrical energy. And usually what a converter is a generator. And like we said before up here, that generators make electricity through moving. So moving that coil wire through magnetic field. So somehow this input energy is creating that magnetic, is helping move that coil wire in the magnetic field. And then what we get is our output energy, and in this case is our electrical energy. Now, generating and distributing electrical energy. So in order to make electricity, turbines need to be connected to a generator. Now, as the blades of the turbine turn, their kinetic energy is transformed into kinetic energy in the generator. And this is what produces the electrical energy. So if we look here in this example, this picture over here, we can see, for example, of water flow coming in. And a lot of processes, a lot of ways of generating electricity use water or steam to turn the turbine blades right here. And we can see here's an example of a little person down here. So how big these turbines are in relation to humans most of the time. So as we see, the water is going to come in here, and the flow of the water is going to turn the turbine. So kind of creating like a tornado in there. Now that turbine is going to turn the generator up here. And that going so fast around and around is going to create that electrical current of electrical energy. Now, different processes that create energy and things that we're used to, especially in Alberta here, and the number one, the biggest way that we produce our energy in Alberta is energy from coal. Now this picture here breaks down the way, and I'm just going to work through it with you. So if we look at A first, lumps of coal are broken down into a powder. This pulverized coal is blown into a combustion chamber of the furnace. Pulverized coal burns rapidly and efficiently. So I mean, it's giving off a lot of energy, being efficient. Now B, so right here, in the furnace, thermal energy from the coal converts water to steam. So like I previously mentioned from that previous slide, you can use water or steam to turn turbines. Then we go to C, so we see that the water is being heated right in here, and the steam is going all the way down into here. Now the high pressure steam flows through pipes and onto the fan blades of the turbine. The turbine spins with kinetic energy, so it's moving. Then we go to D. So D, the spinning turbine turns the generator. The generator converts the kinetic energy into electric energy. So again, we have that input energy, the converter, which is the generator, and it converts the input energy into electrical energy. Then we go to E. The steam leaves the turbine and enters a cooling chamber. The steam is then condensed to water in this chamber and is returned to the furnace. And so it's just a complete cycle, because the water is coming through the steam turbine here, back up where it's cooled, and then we go back through the process. When it's cooled, it's turning back into liquid water instead of being in water vapor, and back into this process here. And then we go to F. And electricity is distributed to customers by transmission lines. So it's being distributed out to our public. And this here, energy from coal, is the main way that we get power in Alberta. Now, energy from coal, there is some advantages and disadvantages. So the advantages, it is relatively inexpensive to use. We have a large supply within Alberta here. And, I mean, it's pretty easy to extract. We're in Alberta and in Canada, we've got pretty good at doing it, and we're getting more environmentally friendly as time are going on, but you'll also see that it's not always, especially down here, as a disadvantage. Mining and processing operations damage the environment, but things are getting better, but they're still not the best way. I mean, it's not a renewable resource, so I mean that we will eventually run out of it. It's not something that can be continually supplied to us. No other disadvantages: the combustion of fossil fuels produce carbon dioxide, which can cause global climate change. So the combustion of fossil fuels may also produce sulfur dioxide, which is a result of acid precipitation, so acid rain, which can cause damage. Its supplies of fossil fuels are limited and cannot be renewed. It's just as I said, it's not a renewable resource. It's not like the sun that we're always going to have as long as we're on this planet here. Now, another form of energy that we can talk about is nuclear energy. And again, going through the same process, starting with A here. So uranium fuel rods are inserted into the reactor core and nuclear fission begins. Now we go to B. Fission reactions produce a tremendous amount of thermal energy, so giving off heat. This energy is carried away from the reactor by a coolant. Then we go to C. So these are the rods in here, creating a lot of thermal energy, and then we go up through the pipe here. So now C, the coolant is taken to a tank where the thermal energy converts water into steam, so it's going to boil this water. Then we go to D. The high pressure steam flows through pipes and is directed through the blades of a turbine. The blades move and make the shaft spin. So this high pressure steam is coming with such force, it's going to create the turbine blades to spin. Then E. The spinning turbine turns the generator. The generator converts this mechanical energy into electrical energy. So again, we have input being converted into electrical energy. And F. The transmission lines take electrical energy to the customers. And one little cool thing here about the nuclear energy is that this diagram shows how a CANDU nuclear reactor produces electricity from nuclear energy. And CANDU reactors were designed and built in Canada and are used all over the world. So something that Canadians can be proud of. Now, with nuclear energy, again, there are advantages and disadvantages. Advantages: the reactors do not release a harmful gas such as carbon and sulfur dioxide such as coal, and a small quantity of nuclear fuel generates an enormous amount of electricity, so you don't need actually a lot of it, which is really good. But some of the disadvantages: you have nuclear waste, which is dangerous to life for centuries. I mean, we don't really have a good way of disposing of it yet. The storing waste safely is expensive and can be dangerous. I mean, it's radioactive, so I mean, it can be harmful if you touch it or get close to it. And accidents can release radioactive materials, and this material can kill plants and animals. It can also cause illness that show up years later. And I don't know if you know of like Chernobyl. So in the Ukraine, there was a nuclear reactor plant there that was creating nuclear energy, and they had a meltdown of their core, and this just emitted tons amount of radiation, and that whole area now is still giving off radiation. It's not safe for people to be around there. Everything that was around there got into their water systems. People were getting cancers and getting very sick, and they still have problems of the Chernobyl disaster. That, I mean, this happened many years ago also. So I mean, great thing, gives off a lot of energy, but can also be very dangerous. Now this slide here just shows the Alberta's electrical transmission system and kind of how it really works out to everybody. And so we can see here, if we look at 1, we have a hydroelectrical dam where water flowing through the dam is going to turn that turbine. We see 2, we could have a coal generation plant. 3, the lines are coming to the transmission substation, and this is where we are converting the input energy into electrical energy. And that's then we're going out on the transmission lines. We can see 5 also, we have a wind power plant. That's a renewable energy source, just like water over here. We're always going to have wind, we're always going to have water. Water, however, though, creates a big floodland out here. Wind doesn't always blow to turn these things, and you also need a lot of them. If we see 7, we have distribution stations. 8, these are large scale consumers. 9, we have more distribution lines. This is what we see all over the side of highways. 10, we're going to the residential areas. 11, to the agricultural areas. And 12, to the commercial areas. So you can see over on this side over here where we're getting all of our energy from, and the process going out this way of where it's all going. So hopefully you learned something today about electrical energy, and thanks for listening.
Made with Doodlecast Pro.